So now if you know, this is what we used to call as basically the arrangement of electrons in the atom. So as we know, every atom is having a different number of cells. That is what the cells we used to represent with what, guys? Two ways we used to represent. Either we used to represent with 1, 2,
Numbers.
4, 5 or 6, or else we used to, and 6 we used to represent, and same way or else we used to represent with what? K, L, M, N,
Alphabet.
O. So this is what we have been studied in the Bohr's atomic model. Is it yes, guys? Please respond. So now if you this is what, so we'll continue here. So if you'll notice it, so now as we know, Bohr said that in his fourth point, the maximum number of electrons which we can fill in any atom, we can use to calculate by the formula called as 2 into n square. So n is number of shell, that is what n is equals to 1, n is equals to 3, n is equals to 4, and so on. So that is, so here you notice it, K, L, M, N. If you notice it, they are finding the maximum number of electrons which we used to find is 2n square. So if you substitute it, 2n square, if n is equals to 1, if n is equals to 1, so as we know, how much will come? 2. So if n is equals to 2, so we used to get how many? 8. If n is equals to 3, we used to get 18. And same way, n is equals to 4, we used to get how much it is? 32. One way. Already we have been we did this one. Is it yes or no? We have been did this already. Correct?
Yes, sir.
This is what we used to call as arrangement of, what is this? Arrangement of electrons. Okay. So arrangement of electrons in the 1, 2, 3, 4 cells. That is what we can say. First energy cell, which is closest to the nucleus, is called as first energy cell, and which is far more away from that is called as last energy cell. And that is only this cell only we used to call as basically valency cell. What we used to call, guys?
Valency cell.
And the electrons present in this last or outermost cell also we can call it as outermost cell. So now this is only we used to call as this outermost cell only we used to call as the electrons which are present in this is called as valence
electrons.
Not valency, valence electrons. Is it okay? Valence electrons, or we can say outermost electrons. Is it okay, guys? Yes,
Sir.
that is. So hope you have been drawn this one. Any doubt in this, you can ask me. Aswita, have you understand, Aswita? Manya and Samaya is not there. Lakshya
Yes,
is
sir.
there. Mahalakshmi also. So now let us go back to this. So now basically, if we'll represent for example, so now this proper arrangement of electrons, the proper arrangement of electrons is only we used to call as electronic configuration. What we used to call? Electronic
configuration.
So this is what the most phenomena from class 9th, 10th, 11th and 12th. So shortcut we can write EC. So electronic configuration, if you'll see, so the electronic configuration of any element you can take. So what do you mean by electronic configuration? Means the proper arrangement of electrons in various cells of an atom of the element is only known as electronic configuration. Means according to their energy level, who is having more energy, closest or farmost? Farmost. Yes or no? So according to their energy, so based upon the number of electrons in an atom, so the proper arrangement of that is only called as electronic configuration. So now let us see what is this electronic configuration. And as we know, electronic configuration, cells will follow K, L, M, N cells. What they will follow? They will follow the maximum number of electrons which can be accommodated in any energy level of an atom is given by a formula. What, guys? 2 into N. What will follow? The number of electrons. N is equals to 1, 2. N is equals to 2, 8. N is equals to 3, 18. N is equals to 4, 32. N is equals to 5. 5 is equals to what? 50. And N is equals to 6, 72. Like that.
72.
Yes or no? So that is what we have been studied. So now, so the outermost cell of an atom, we can say we cannot accommodate whatever it is. Remember, all of you, maybe the capacity of, for example, I will draw like this structure. Always you should remember, if this is the nucleus, what is this called as, guys? Nucleus. And this is the outermost shell. What is this? What is this, guys? Outermost cell. So what is the capacity of this one? Can anyone say? KLM. What is the K shell capacity? K shell capacity 2. L cell capacity 8.
8.
M cell capacity what? 8.
18.
But remember, whatever the outermost cell, do you understand what I'm saying, guys? Try to understand carefully. Whatever the outermost cell, we cannot fill more than 8 electrons. Did you understand what I'm saying? More than 8 electrons, it is not possible to keep in the 8 outermost cell. Understand, right? Its capacity is different. This is called as what? Capacity. Do you understanding, guys? But what do you mean by this one? More than 8 electrons, we cannot fill in any outermost cell or a last cell. So this is only called as octave rule. Understanding, guys? Because so octave rule will say a maximum number of electrons which we can fill any outermost cell. Any what, guys? Any outermost cell is how many, guys? Is maximum 8 electrons. So then only the atom will become stable in nature. Atom or element will become what? If it will become stable in nature. So this is what we used to call as octave rule. So maximum number of electrons which we can fill in any outermost cell. How many?
8 only.
8. So that principle is only called as octave rule. Understand, everyone? So now, if you take, for example, only some elements is having only one shell. That shell is called as what? Only one shell it is having. What is that shell called as, guys?
K cell.
K shell.
K cell.
In this, is it possible to accommodate 8 electrons? Its
No,
capacity.
No, sir.
Only 2.
2. So then,
Two
this cell, if any atom having only one shell, and that shell name is called as what, guys? Only one shell. And that shell is K shell, then the maximum electrons which we can keep in the outermost cell, then the K shell itself outermost, yes or no? K shell itself outermost, in this, the maximum number of electrons which we can keep is 2 only. So this rule is only we used to call as duplet rule.
Duplet rule.
So in this case also, atom will become stable in nature. Atom will become, guys, stable in nature. Did you understand what I'm saying? So this duplet rule is applicable only when, guys? Only
in hydrogen.
Shell is there.
And that K shell itself a what? K shell itself is the outermost
Shell.
The number of electrons which we can fill, how many? Daron, Tamil Selvan, which can fill is 2. That is only called as duplet rule. Then also it will become stable in nature. So understand, everybody? If other than K shell, if any other cell is there, so how many maximum number of electrons we can fill in last cell? Their capacity is different. See, capacity is different. Capacity we can find by using which formula, guys? We can find by using a formula
2n square.
If it is a last cell, then maximum how many electrons we can keep in the last cell?
8 electrons.
8.
So that rule is only called as octave rule. So the valency, you might be see, metals will donate the electrons, yes or no? Metals will donate electrons so that it will turns into positive ions. Understand? Same way non-metals will observe or else receive the electron so that they will turns into the
Negative ion.
Positive ions, negative ions, only what? Here, loss of electrons, and here, gain of electrons. That is only. So, this loss or gain, both is happening because of why? Only reason to become stable in nature. Understanding? Only to become stable in nature. That is only stable in nature is only the reason behind it. Is it okay, everybody? Yes, please.
Sir.
Yes.
Yes,
So
sir.
that is what you have to understand it. So the capacity is different and the outermost electrons is different. If only one shell, that shell itself a K shell, then what is the maximum number of electrons?
Two.
Only. What is the maximum number of
Two
electrons?
electrons.
We can.
Two.
That is
Electrons.
only
Two.
that itself is become stable in nature. That is why you might be see helium is having how many shells? Helium is having only one shell.
Only one cell.
That is having only two electrons. So that is why it is become stable in nature. It is satisfying duplet rule. It is satisfying what? Duplet rule.
Duplet.
It is a stable
It is a
gas.
noble
Or
gas.
we can say noble gas. Understand, Devarsini? We can say noble gas.
Yes, sir.
Because it is becoming
Noble gas.
in nature. Okay. So now you can see. So let us take
Yes,
now.
sir.
Yeah, if you'll understand this, then we'll go with the proper arrangement of electrons. And later I will say what is the valency, combining capacity and all. So now electronic configuration of first 20 elements, if you'll notice it, is very, very simple. So if you'll follow, first, what is the first electron? What is the first atom, basic element? Hydrogen.
Hydrogen.
So hydrogen, it is having how many cells? Hydrogen, if you'll take how many
One
cells?
cell.
Only one cell.
So if you're having hydrogen, so hydrogen, if you'll take only single cell. So single cell, one
Yes,
proton,
sir.
one proton and one K shell. So K shell having how many electrons? Only one electron.
Only one.
Atomic number Z is equals to 1. Atomic mass also, it is equals to 1. So what is the number of cells here? Only K shell. Understand, everyone? So that is what you have to remember. So K shell. So next, if we take helium. So helium, how many cells? Helium also 2
One
electrons
shell.
present. It is also having K shell. So the atomic number is equals to Z. So if we take lithium, lithium is the third one. So first element, 20 elements, your textbook you can see. So lithium symbol is Li. So lithium is what? Atomic number is 3. So means in the sense of what? So the maximum number of electrons which we can fit in first outermost cell, how many? 2. So now
Two.
2
3
and then
minus 2,
1.
how many remaining? 1 electron.
1.
So only 1 electron we can keep in the next cell. So now, if it wants to become stable in nature, what it will do, guys? Maitrans, Darun, anybody smart way you can tell. If it wants
It
to
will
be,
lose.
Donate
It will
one
lose.
electron, sir.
that is only. See, gaining 7 electrons is difficult. Yes or no? So that is
Yes,
what
sir.
this electron is
It will
removed.
lose 1 electron.
This electron is removed, the cell also will remove. Yes or no? Then finally,
Yes, sir.
lithium is having only single cell. That cell itself what? That cell itself K shell. So K shell is how many electrons maximum, guys? It is having
2.
electrons. So that it is satisfying which role? It is satisfying
Duplet rule.
duplet role. Lithium ion plus 1 will become stable in nature. Did you understand, everybody, what I'm saying? Please respond, everybody.
Yes, sir.
Like that, if you keep on studying your textbook they have given, so we can say this is only even called as electronic configuration also. This electronic configuration means electron distribution. So what is the lithium electronic configuration? Lithium electronic configuration is what?
1.
L cell.
2
So
and 1.
is 2 and L cell is 1. So the electronic configuration of lithium, electronic configuration of lithium,
Lithium.
electron distribution is 2, 1. Is it okay, guys? Everybody, please
Yes, sir.
respond. Next, if you keep on taking, for example, let me take aluminum. Aluminum is 13. You might be
Yes,
know.
sir.
So aluminum is 13. So how many cells? K, L, M. So now first K shell how many?
2, 8,
13 minus
2, 8, 3,
is
sir.
equals to how much? 11.
11.
Second one maximum how many? 2, 8, 18, 32. Correct? Now second cell how many? 11 minus 8. So 8 gone.
11 minus 8.
11 minus 8 how much?
3.
3.
sir.
M shell it is having 3. So now if you see aluminum can donate maximum how many electrons? This is only
3
waste
electrons.
outermost cell. What ways to call?
And donate.
Outermost cell. So receiving it wants to become stable. It wants to become stable. How many electrons it needs to gain? 5 electrons needs to gain. Yes or no? So it is
Electron.
so that is why it will
But
lose
it is
3
difficult,
electrons.
sir.
So that it will become what? Aluminum ion. Aluminum ion, what is the electronic configuration? Only 2, 8. So that
2,8.
stable in nature. Puriyamara? So once
Yes,
this
sir.
electrons is removed, this M shell also will remove. Is it okay, guys? Mahalakshmi,
Yes, sir.
Mukesh, Karthik, understand Shakti? That is what you have to
Yes, sir.
remember. See, 10th class, every chapter we are having importance of this. Be careful. So like that, if you take, let me take till 20th element. What is the 20th element? Calcium.
Calcium.
So calcium is the symbol of Ca. So if we take calcium,
C.
K-L-M. Let me take one more cell is there or not, we'll check it. Now first cell, how many? 2. Next 8.
2, 8.
You can check it.
2882, sir.
2, 8, 8, 2, sir.
2882.
What I said. So here onwards, sir, you can say, sir, my M shell only it should be remaining all the electrons. Yes or no? 10 electrons. Yes,
Yes,
sir.
sir.
Yes, but it is not following here. That is what I'm saying. So till 18,
Yeah,
we can
only
follow.
18%.
Yes, actually it will follow 288 and 2. L shell, KLM.
Two.
L shell, it is having 2 electrons. So this is what here people may ask, sir, why can't we write KLM? That is 2810. Is it yes or no? You might be having this doubt. Yes or no? So here,
So that is wrong.
yes, this is the wrong way of writing. So till 18 elements, we people can write in this method, understanding. But 18 onwards, it is not possible to write by this general method of electronic configuration. So for that only, from the 18, we will follow a principle called as I told you, what is the principle? How about, understand?
Half
So this half-bow principle only will represent in the form of buses. So each cell is having a different number of buses.
principle.
Each bus we can fill some number of electrons. So that is in detail we'll study in the tomorrow's class. So you no need to worry. But what you will do means till 18, you no need to having any problem. Understanding? So till argon, what is the element argon called as? Argon is 18. Understand, Ra? So
18.
Sir.
so how we can represent KLM? So 288. That's all. Clear, everybody? 288. So that is what. See here, M cell is
Sir.
electrons. So is it need to gain electron or loss electrons? No need to take place. So that is
Sir, it is
0 energy,
very
sir.
stable.
Stable in nature.
stable gas, or we can say noble gas. Understanding? Or inert.
Noble gas.
So that is so till 18 electronic configuration is very easy, understand, but after 18 we have to follow a different method of approach. That is what we used to call it as half-bow principle. In the next tomorrow's class I will say, and I will teach you also how to do it very in detail. So till 18 everybody should learn the electronic configuration. Very simple, correct? We can generally also will say, can anyone say first one 1, second one 2, third one 2, 1, fourth one 2, 2, fifth one 2, 3, fifth one, next one 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Next one what? 8 after what will come, Rael Mukel? 8 after what will come?
2, 1.
1. Next
2,
one
8, 1, 2, 8, 2.
2, 8, 2. 2,
next one
8, 3.
next one 2, 8, 5. Next one 2, 8, 6. Next one 2, 8, 7. And last one 18th element. What will come?
2, 8, 8.
8.
That starts with the 1. Next one 2. Next one 2, 1. Next one 2, 2.
2,
Next
8, 8,
when 2, 8 will come. To next after 2, 8, 1 will come. Same way 2, 8, 2 will come. 2, 8, 3 will come. Finally 2, 8, 8 will come. So till here it will follow above principle. It will follow general electronic configuration. After this we have to follow some techniques. That is what we will study. Half-bow technique to write after 20. Sir, how to write the electronic configuration and valence electrons also, that we will study in the next class.
Yes, sir.
With this I will leave, so you can get relaxed. Thank you everybody. Bye.